So bonding in coordination compound. Here we have different type of um, theory. First theory is the valence bond theory. This valence bond theory says that we have metal and we have ligand. Okay, metal react according to the ligand. Ligand will decide how metal will react, and based on how metal react, it will decide what hybridization. What will be the hybridization one? Because in case of hybridization, all the orbitals should have the equivalent energy. All orbitals should have equal energy, and other than that, it will decide the geometry. What are the different type of geometry? It could be octahedral or tetrahedral or square planar. If you have six ligand, then octahedral geometry. If you have four ligand, it could be tetrahedral and square planar. That will decide. Okay. In this hybridized orbital, what will happen? Ligand will donate its electron. So if ligand want to donate its electron, orbital should be available in the metal. We want to see how many orbital are available in the metal, and based on that hybridization will be decided. Okay, what is the benefit of this theory? To know the benefit, first we should know ki we should be aware about the electronic configuration of every element, their atomic number. If you know these two things, you will get to know ki whether a compound is dimagnetic or paramagnetic. How? If all electrons are paired, dimagnetic. If even you have one unpaired electron, then it will be paramagnetic. So in paramagnetic, at least one unpaired electron. If all are paired, then dimagnetic. Okay. Geometry, octahedral, tetrahedral, or square planar. Hybridization, sp3 or dsp2 or some kind of hybridization. Spin, low spin or high spin. If it is low spin, it means most of electron are paired. If it is high spin, it means you have unpaired electron, and unpaired electron means paramagnetic. Low spin means dimagnetic. Understood?
Yes, sir.
Huh. If coordination number is 4, then one is S3p. sp3 hybridization is possible, and in sp3, you know, geometry will be tetrahedral. Second possibility is d orbital of the metal is also involved. So 1d, 1s remaining 2p because total should be 4. Second possibility is this. In this case, you will see here outer orbital are used, but in dsp2 inner orbital are used. Inner d orbital are used. Inner orbital is used. Okay, same here. Here you have outer d orbital, but in this situation, inner d orbital. Inner d orbital are used. Okay, and for this we have different type of compound. Example, you will get this compound. If cobalt with 6 ammonia is given, you have to tell how this compound will react, what will be the geometry. Okay. So in this compound, what you want to know using the valence bond theory, what is the electronic configuration of cobalt? Example, Cobalt atomic number is 27. Sarah, what will be electronic configuration of cobalt? 3d7 4s2. Correct? 3d7 4s2. Now you have to look at the nature of ligand, whether it is a strong ligand or weak ligand. Ammonia is a strong ligand. That we'll get to know in the next crystal field theory, but here you can focus it is a strong ligand. What is the role of strong ligand? They cause pairing of the electron. They cause pairing of electron. And whenever there is a pairing of electron, you will see most of time, not always, there will be low spin. Electron will be paired, so low spin. Most of time, it is dimagnetic if even number of electron. Dimagnetic in case of even number of electron. Okay. And last, most of time, inner orbital will be used, not outer, inner, because it will vacant. Why it is vacant? Because of the pairing. Example, you in normal situation, mm, in normal situation, where is this? In normal situation, D have 7 electrons. So let's see if these are the 5 orbitals. One, two, three, four, five. And there are total 7 electrons. First, you do half pairing, and then you will add 2 electrons. Total 7 electrons are done. What will happen if you have weak ligand? It will remain same. But if you have strong ligand, all these electrons will start pairing. One, two, three, four, five. So what will happen? It will cause pairing. Directly you can write total 7. So what is happening in this situation? If you have 7 electron, pairing happened, it is because of the strong ligand. Now, if you need to vacant the space to accommodate electron from the ligand, because all these are the property of metal. It is because of the metal purely. You have to leave some space to accommodate more electron. You have to vacate the orbital. In first situation, inner orbital are not available because everything is filled. But in second case, last orbital is free. Correct? That's why it is inner orbital. Inner orbital are used here to accommodate electron. But it is not dimagnetic. Why? All electron are not paired. Understood? Now come to the this specific compound. So what happened? We know cobalt is 3d7 4s2. But here we have cobalt 3 positive. Jordan, what will be the electronic configuration of cobalt 3 positive?
3d6.
3d6. Why? Because we removed 3 electron from this, 2 from S, 1 from 3d6. Now there are two possibility. If cobalt have 6 electron and you have weak ligand 1, 2, 3, 4, 5. If you have weak ligand, what will happen? 1, 2, 3, 4, 5, and 6. Correct? Because weak ligand cannot cause pairing. It will happen in the weak ligand. And because you have unpaired electron in this case, it is paramagnetic. Unpaired electron, paramagnetic. Correct? And unpaired electron are usually free. So this is also known as spin free system. and inner orbital are not vacant. So you have to use outer orbital. So this will be outer orbital complex. Outer orbital. Anybody have doubt in this?
No, sir.
If you have strong ligand, I'm not talking about any ligand here. I'm just talking about ki what happen if there is a strong ligand and weak ligand. Why this is happening? 1, 2, 3, 4. So what will happen? Strong ligand will cause pairing. 1, 2, 3, 4, 5, 6. This is because of the strong ligand. In this strong ligand, all electron are paired, no electron is free. So this will be diamagnetic. All electron are paired, so they cannot move freely. So spin paired. And here you can use these two orbital because these are free. You can use this orbital. So you will say it is the inner orbital complex. Tell me everyone, anybody have doubt? What is the impact of the strong ligand and weak ligand?
Sir.
This spin paired is also known as low spin, and spin free is known as high spin. High spin means electron can freely move. High spin means movement. Spin free means free movement. High spin. Now we know this ammonia is a strong ligand. So ammonia will cause all the impact of the strong ligand. So what should happen in this case? Inner, and you have 6 ammonia. So you know coordination number is 6. Your hybridization should have 6 number. These d orbital, inner d orbital are free. So D2, 1s and 3p. Make sense?
Sir, could you explain the hybridization part?
Because you know total number is 6. Whether you take strong ligand, weak ligand, how do we know? It is given in the question. It is given in the situation. Ki see, here you have 6 ligand. That's why coordination number is 6. So total number will be 6. First inner 2d orbital are vacant. After d you have s, and then you will have p, 3p. So 2d orbital are free to accommodate electron, 1 s orbital free and 3p. Total 6 orbital are free. 6 coordination number means you need 6 orbital free, so you can take electron. Any doubts, Sarah?
No, sir.
But in this situation, if you take weak ligand, what will happen? Inner orbital are not free. If you have any 6 ligand, what will happen? You need outer orbital like 1s, 1s, then 3p, 3p, and then there will be d outer. So 1s, 3p, and 2 these will be involved. In this case, hybridization will be sp3d2. Got it?
Sir,
Yes, Pratigya.
how to calculate hybridization?
How to
Calculate hybridization.
how to calculate? You have to check what is the total number of ligand. Example here, total number of ligand is 6. So you know your coordination number is 6. In case of unidentate, remember I am talking about unidentate. You have to first check coordination number. If you know coordination number from the last class, then total number is 6. So you need 6 orbital. How to check orbital? 1s, 3p, d2. Total number 6. Understood?
Answer.
Even here, coordination number 6, 2D, 1S3, and 3P, total 6. Ask any other question. As of now, I explained this without using NCRT. Then I'll read NCRT. Tell me any doubt.
No, sir.
No, sir.
Then read NCRT. We can predict the geometry. Yes, we can predict whether it is D2SP3 or SPD2, octahedral or tetrahedral. It is dimagnetic in case of this. Yes, we know why it is dimagnetic in this compound, cobalt 6 ammonia, because ammonia is a strong ligand. What is the reason for the dimagnetic? Ammonia, strong ligand. So, dimagnetic in case of this. What is the reason? Reason is ammonia is a strong ligand. Okay. You have 6 pair of electron, one from the ammonia occupied the hybrid orbital. So geometry will be octahedral. How do we know it is octahedral geometry? Because 6 coordination. And it is dimagnetic. Why? Because of the ammonia, strong ligand. In this case, inner d orbital will be used 3D because all these orbital, cobalt orbital are 3D orbital. Correct. So inner d orbital are used in hybridization. That's why inner, it is called inner orbital or low spin, because all are paired, they can't move, or spin paired as the name suggests, electron are paired. Understood? Any doubt? But if you take cobalt F6, you have to focus कि this fluorine is a weak ligand. This fluorine is a weak ligand. Weak ligand cannot cause pairing. Weak ligand cannot cause pairing. So if normal cobalt have these 3d6 electron, you cannot cause pairing. Now outer orbital will be used 1s, 3p, and outer d orbital. Total 6 orbitals should be free to add electron from the ligand. So 1s, 3p, and 2d orbital are used for this. That's why sp3d2 hybridization. And in whenever hybridization is this, your geometry will be octahedral again. But it will be paramagnetic. Why it is paramagnetic? Because of the free electron. These electrons are unpaired. These electrons are unpaired. So free electron. Okay. Done. So what is the conclusion of this? You should know what is the nature of the ligand, strong or weak. Second, you should know what is the electronic configuration of the atom, metal, and what will be the electronic configuration in the charge condition. Like if cobalt is 3 positive, what will be the electronic configuration in cobalt 3 positive? If inner d orbital are used, so it will be inner orbital complex. Outer used, outer orbital complex. If unpaired electron, paramagnetic, high spin, spin free. Dimagnetic, all are paired, so spin paired, low spin. Done. Any doubt, guys?
So just a question, sir.
Yeah, sure.
So I'm finding it difficult to remember the electronic configuration of metals. How is there any way you could help out with that?
You need to focus mostly on the 3D orbital. So it is in the sequence, and if you understand the sequence, then it will be easy for you. Did I wrote anything here? Example, here I wrote important element that electronic configuration is used. Example, Fe atomic number 6, so D6. Cobalt 7, 7. Nickel atomic number 8, 8. Correct? These are the three popular. Then chromium 24, this is special case because of the half field. Manganese normal 25 5. 29, this is again exception. It should be 3D9 4s2, but full filled is more stable. And zinc normal. And these are their most stable ion, their electronic configuration. So, Jordan, for this, you should know the complete 3D series. You have suc- like scandium, Sakti, व कर में फेंको निकुंजन. These are the 3D element.
Yes,
Okay,
sir.
3D series extremely important, and you should know atomic number because it will be in the sequence. So atomic number is not big issue. That's why in the beginning when we did electronic configuration, this was extremely important because I believe 80 to 90% chapter is all about electronic configuration. If you know electronic configuration, you can solve most of the question. You want to calculate magnetic property, you need electronic configuration. You want to understand the coordination compound, you should know D block electronic configuration. So it's more about electronic configuration, both D and F block and this. And that's the reason why I did uh, D and F block before, because electronic configuration. So total electron 18. And here atomic structure also come into the picture, because in atomic structure you have topic Haber principle, which explain us ki how electron will be filled according to the atomic number. Correct? Right? Like
Yes, sir. Yes, sir.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4, 3d10, 4p6, 5s2, then 4d10, correct? 4d10, 5p6, 6s2, then 4f14, 5d10, 6p6, 7s2, and then 4f14, 6d10, 7p6, and done. Correct. I know.
Yes, sir.
Example, if I have to write electronic configuration of scandium, so what you will do? You have 10 electron here, done. You have 8 electron here, done. 18 electron will have noble gas configuration. This is noble gas configuration. It is stable, so no need to know about this. Okay. Now in your D block, we are focused on this part. First 4S and then 3D. Chala, bas maan लो. So this is the in electronic configuration we are really bothered about. 4s2 and 3d10. And the same thing happen here. 18 will remain same. 4, if you remove 18 from this 3 electron, 3d1, 4s2. Here if you remove 18, you have remaining 4 electron, 3d2, 4s2. 3d3, 4s2. 3d4, it should be 3d5, it's 3d6, 3d7, 3d8, 3d9, it should be, and 3d10. It should be, but there are exceptions in case of chromium and copper. Why? Because you know half-filled electron are highly stable. So one electron jump from the S and it become 3d5 4s1, because everything at least half value highly stable. Same 3d10 Fulfill are highly stable, so S will donate one electron and 5 orbital of D will be more stable. This is the electronic configuration. But again, if you do it for 5-10 times, you will be good in it. Example, I did so many times, so I knew ki cobalt is 27. Electronic configuration will be 3d7 4s2. And if I remove 3 electrons from the cobalt, then I will remove first electron from the S, then from D. So 2 from S, 1 from D, it will be 3d6. Understood?
Understood, sir.
So that's why we have to focus on the basic. Trick, everybody can give you trick. Okay, use this trick, you will remember. But you will never understand the chapter if you don't do this, because DNF block is also there. You need electronic configuration in the P block also. So too much trick will not help. Come to this tetrahedral compound. In tetrahedral compound, you have only 4 ligand. Octahedral compound, you have 6 ligand. Example, if you compare all this stuff, then cobalt had 6 ammonia, and in second situation, cobalt had 6 fluorine. Both are octahedral, correct? But in next compound, nickel have only 4 chlorine. It means coordination number will be 4. Here, coordination number will be 4. So only 2 possibility are there. If it is sp3, then tetrahedral. dsp2, then square planar. Any doubt? We will not talk about D2 sp3 or sp3 d2. We will not talk about octahedral. Only these possibility. If this hybridization, only these 2 things can happen if you have only 4. Now, the easiest way to understand which is a strong and weak ligand, all the halogen are weak ligand. Whether you take fluorine, chlorine, bromine, or iodine, all 4 halogen are weak ligand. Okay. In last case, we had fluorine, it was weak ligand. Chlorine is also weak ligand. If it is chlorine, then most of the thing will be done. Example, what is the nickel normal electronic configuration? Atomic number 28. So in the end, whatever is the number you write, except 2 exception. Okay. If you remove 2 electron from this nickel 2 positive, so electronic configuration will be 3d8. We know chlorine is a weak ligand. It cannot cause pairing. So you can see diagram. It cannot cause pairing, 8 electron. And no d orbital are free. So what will happen? 1s and 3 p orbital will be involved, total 4. So 1s, 3p orbital use sp3 hybridization. Any compound that have sp3 hybridization have tetrahedral geometry. And you know many electron are free. 2 electron are free here. So this is known as spin free. It is spin free or high spin. Spin free or high spin. And it is paramagnetic because unpaired electron. And no inner orbital are used, so this is outer orbital complex. Tell me, anybody have doubt? Right? Anybody have doubt?
No, sir.
Huh. So tetrahedral compound because sp3 hybridization. In case of this compound, nickel have 2 plus electronic configuration will be this, and you know hybridization scheme. Okay, it will be paramagnetic because unpaired electron. But if you take nickel tetracarbonyl, in this case, electronic configuration of nickel is still same. 3D8 4s2. Okay, but carbonyl is very strong ligand, extremely strong ligand. What will happen? It will cause pairing of even these two s electron and will make it 3D10. Though carbonyl is extremely strong ligand, like strongest ligand. So this strongest ligand will cause pairing of even s electron, and because of that, we have hybridization sp3. Okay, sp3, and this strong ligand is responsible for the pairing. It is dimagnetic. It is spin paired. It is low spin, but sp3 hybridization and tetrahedral. Why it is special? This is special because whenever you will hear about the strong ligand, you will think about the inner orbital will use, and it should be square planar, but it's not. So there is high chance question will be asked from this electronic configuration, nickel tetracarbonate. Got it? And remember here, nickel do not have any charge. That's why it is possible. Okay. But if you see next situation, nickel tetracyanide. Here nickel have two positive charge. So 3D8. Cyanide is a strong ligand. It will cause pairing. When you see this pairing, one orbital is free. Okay, all electrons are paired, so this is spin pair, low spin, dsp2 hybridization, square planar, dimagnetic. Correct? dsp2 hybridization, low spin, square planar hybridization, and everything. Any doubt, guys?
No, sir.
And last point, in reality, hybrid orbital do not exist. It is just mathematical calculation to understand the atomic orbital. But in reality, there is no existence of the hybrid orbital. Hybrid means mixture. Magnetic property we already know from the last chapter D and F block. This formula you already did many times. We did question. So I will not touch this part. But one thing will help you out. Which is the strong ligand and weak ligand? Example, this T2O4 oxalate is a strong ligand. I will write here strong and weak ligand based on the question we had so far. Carbonyl, cyanide, ammonia, then C2O42 negative oxalate. All these are strong ligand. Extremely important to understand this. These are strong ligand. But if you take halogen, I told you in the last topic, if you, I wrote here somewhere, yeah. If you take any halogen, fluorine, chlorine, bromine, iodine, then it is weak ligand. Now, if you understand this concept, look at this. Strong ligand will cause pairing and mostly dimagnetic. And weak ligand do not cause pairing, so mostly paramagnetic. Imagine here. Okay. If you see MnCl6, chlorine is a weak ligand, it will be paramagnetic. Okay. But if you see CN6, it will be different. Same fluorine will be paramagnetic. But
सर
C2O4, yes, Pratigya,
मैं 2 मिनट में आती हूँ.
ठीक. Okay. But remember, when you want to check whether a compound is paramagnetic or dimagnetic, you have to write electronic configuration. Example, if you take manganese 3 positive, then you have to see how many electron are present. Example, what is the electronic configuration of manganese, Barinder? 3d54s2. Here manganese is present in the manganese 3 positive. So manganese 3 positive will be 3d4. Correct. If you have strong ligand, it will cause pairing 1, 2, 3, 4, and 5. You have 4 electron with the paired situation. Correct. So what written here? Ki manganese MnCl MnCN6 has magnetic moment of 2 unpaired electron is wrong because there is no unpaired electron. There is no unpaired electron, so this is wrong. Got it? There is no unpaired electron because here it will cause pairing. All other things are normal, so don't worry about other things. If you have halogen will be weak ligand. Ammonia, cyanide, carbonyl, and C2O4 will be strong ligand. And this topic is done. I will not show answer. All of you solve this question because I taught everything already. Spin only formula and send in the group. Done? If you solve this question,
So it will be tetrahedral, no?
let's see. Magnetic moment of this, there are only two possibilities. Whether it is tetrahedral or it could be square planar because coordination number is 4. Octahedral is definitely not possible. If this is the situation, then you know it is approximately 35. The number of unpaired electron will be 5. Number of unpaired electron will be 5 and value is 5. Number of unpaired electron is 5 in Mn2 positive. It means all orbital are unpaired like this. So outer S and P3 orbital are used. Okay. sp3, so it will be tetrahedral. One thing, wait. I think I told one thing wrong here. Let me. If you see this electronic configuration of Mn 3 positive 3d4, so you know 1, 2, 3, 4, 5. There are total 4 electrons of manganese 3 positive. Correct? Now, cyanide is your strong ligand for sure. Strong ligand. Okay, Pratya. Strong ligand. So it will cause pairing. But maximum orbital you can use from the inner side is only 2, not 3. In presence of cyanide, what will happen? Number of orbital will remain same. Correct? So if it cause pairing, this electron will go into this. It will cause pairing, this and this. And outer 2 orbital will be free. This D2. And electronic configuration will be D2 sp3. So it was correct. Here you have 2 unpaired electrons. But because even I made mistakes, so I'll make sure ki I'll mark this separately, 2 unpaired electrons. Okay. Even in the future, if I feel ki I made mistake somewhere, I will correct it. ठीक झाला हैं? एक बार उसका तरफ फोन करो रुक जाता हूँ 2 मिनट रुक अंडरस्टूड गाइस रीजन because you need only 2d orbital not 3 so complete pairing is not possible in this case only partial pairing and that's why it is given in NCERT and it is extremely important got it so mark this mn6 mncn6 ठीक है बस वो आऊँ मैं थोड़ी देर में कॉल करूँ got it guys any doubt
No,
No,
sir.
sir.
even in the notes I will write it separately so we don't make mistake or we don't forget this special molecule MnCN6 this is P negative in this case what will happen you know here manganese is present in manganese 3 positive state manganese 3 positive state means 3d4 in 3d4 if you take orbital 1 2 3 4 5 so 1 2 3 4 in presence of this cyanide which is a strong ligand This strong ligand will cause pairing, and this pairing, what will happen? Only one electron will come here, not two. Only one electron from this will come here. So it will be only this, and last two orbital will be free. That's like 1s and 3p. So 2d 1s 3p. It will be d2 sp3 hybridization. It will be inner pair like any strong ligand. If you write the property of this compound, you will write in the same way. Okay? It will be inner orbital. But there will be exception also. How? Because here it is paramagnetic. One thing. Because two unpaired electrons, so spin free or high spin. Okay? Spin free, high spin, paramagnetic. And because here number of unpaired electron is 2, you can calculate your Bohr magnetic moment also. 2 into 4, it will be under root 8 Bohr magneton. Okay. Done. Tell me guys, any doubts? This
Sir,
is yes, Anvita.
won't it be D3sp2?
No, it won't be, because maximum d orbital can be used here is only 2. That is why it is special. That is why I wrote it separate from NCRT. The maximum orbital you can use here is only 2. One will be S, three will be C.
Sir, it's strong ligand, no? So why won't we pair it?
Because you have maximum like 2d orbital in the octahedral configuration, not 3. Maximum 2 orbital are used in this situation. And second reason, in this case, there will be splitting also, T2G and EG. That we'll discuss in the next topic, crystal field theory. That is for such kind of topic where we have confusion, why it is like this. We have crystal field theory. Got
So
it?
even I'm confused. So
What?
like CN is still a strong ligand, but then in the second and third orbital, the lone electrons, unpaired ones, why won't they
Uh,
get paired? Because CN is one of the strongest. It's just second to CO in terms of splitting strength
correct.
now.
So is this an
But
exception? Because like in other cases we pair it up, right?
this is special because of this. Your 5 orbital. And that's why special, like that's why we are spending too much time only on this. So you have 5 orbital. These 5 orbital will further break down into T2G and EG. Here 3 2 orbital, here 3 orbital.
So wait, you
So what
don't
will
want to CFT.
yes, in crystal field theory we will discuss this topic. Here example, you have 4 electron. What will happen? First there will be 3 unpaired electron, right? Now whether fourth electron will go to this EG or not, it will depend upon the ligand. Because cyanide is a strong ligand. What will happen? Pairing will start. So what should be the configuration? This it is not exception. This can be understood only based on the this crystal field theory. There is a splitting of 5d orbital into 2 and 3, T2g and EG. And when you understand this key, first electron will be filled in T2g, like these three orbital. Three unpaired, fourth will be paired because of the strong ligand. Because cyanide is a strong ligand, now pairing will start. So it happen like this only. The reason why mostly we see ki if example you have strong ligand in case of cobalt. So how many electron will be there in the cobalt? 6. Let's take this is 3d6. What will happen? First three unpaired, then three paired. So we don't see this situation. That's why we have crystal field to explain this nature. Ki this 5d orbital further split into 2 and 3. You will always first fill these three orbital. First pairing will start in these three orbital. First normal like one orbit, one electron in each orbital, and then pairing.
So I still didn't get it. Like usually we pair it up, right, with cyanide also. Like in other
Yes,
cases.
but
Why?
because you mostly see when there is a electron more than 6. Example, if you take nickel, you take nickel 2 positive. What is the electronic configuration? 3d8.
Oh,
So if you see here, what will happen? This pairing happened, and now it will move to this. Keep pairing happened like this. One orbital is free, and if it is NiCN4, so it will be one d orbital free. Because as of now we were considering this 5 orbital as a single unit. Now we get to know no, no, it further divided into two. Lower one will fill first. For that you need minimum 6 electron. Understood? Any doubt? Everybody understood? Let me know.
so this is happening only because it's 3D5 and not more than 3D5, like 3D6 or something.
Yes. In 3d5, 3d5 is unpaired always because odd number of electron.
So
3d6 fully paired.
basically, if we write D3sp2, it will like act as outer shell, and that is not the case for strong
Yes.
liquid. That's why we are not.
Yes. Why I said before key you can use only 2d orbital because you can use only this easy orbital outermost, not
So
innermost.
basically, we can say this is an exception, right? Like, because usually it
Not
won't
exactly exception when we read the crystal field theory because crystal field theory explain the same content.
happen in VBT if we just ignore.
So
Yeah, in VBT it is exception in VBT.
Yeah.
Here we'll discuss the same thing. You have T2G and EG depend upon the strong ligand and weak ligand. We have the same thing. That's why crystal field theory explain better way
So
compared to
according to
the
CFT, I can understand why this is happening, but like if we like try to understand through VBT, I'm getting
yes.
confused.
Only from the VBT perspective, this is look like exception
Then
for
it's
sure.
fine. So got it.
So,
Yes,
so
Jordan.
basically,
Hmm.
because the d orbital is not exactly an outermost orbital, so therefore the effect of the ligand is a little less compared to the outermost orbitals now. Is that what
Yes.
is
Yes.
happening?
Like first you have lower T2G
Yes,
and you are
sir.
filling electron. Same thing is written here also. See how things happen. Ki how pairing will start.
So, but then the thing is, depending on metal and ligand, how to determine that? I mean, on ligand, because of the scale which we have, we know what will happen exactly. But for
Hmm.
example, in this case, instead of the ligand being CN, what if it was CO? CO is being the most strongest ligand. Then would it completely be diamagnetic or?
No, it will be still same.
Okay, so the differentiation part is where I'm getting confused. How in other cases?
No, because in other case, example, if you take in this nickel CO 4 times, here you are comparing ki sir, I have seen It was 3d8 4s2, and this carbonyl was causing pairing of these two electron, and it convert into 3d10, right?
Yes, sir.
But you have to imagine कि after transferring two electron from s, it became highly stable because of the fulfilled d orbital.
Ah, okay. So it basically favors instability.
It is basically favors stability, not instability.
Okay, sir.
Okay. Tell me, guys, anybody have doubt in valence bond theory?
No, sir.
Anything? Let's do limitation, then we can focus on the most important topic of this chapter, crystal field theory. And this year in 2025, we got question from the crystal field theory where it was about the energy. Right? So I will take one more class. I will stop after this and we'll solve some question from this now. But I'll take one more class for crystal field theory and the remaining topic. Remaining topic are easy. Crystal field theory you need from the scratch.
So when will you take?
What was the time I wrote? What is it?
You told 2 o'clock.
2 o'clock.
Yes, sir, it was 2 o'clock.
Yeah, I'll take at 2 o'clock. If I feel ki I need one more class, then I'll let you know. But 2 o'clock for sure I'll take. That's the reason ki if I start the crystal field theory and I said ki 2 o'clock, then I need at least 1 more hour to complete crystal field theory. By then you will be so tired. To overcome this, we'll finish it by 1 o'clock and you will have 1 hour break. Okay.
So,
Huh.
like in today's paper, like
Yes.
the whole chapter will be there, no? Coordination
Yes.
compound.
Full chapter will be there.
Like, will there be less questions or like equal as periodic classification?
Every like more or less there will be almost equal number of questions in every chapter from every chapter.
Like the whole syllabus?
Yes, whole slips.
Okay.
Yeah. So there are many benefit of this valence bond theory. Benefit like it explain how compound form. It explain how there are different structure octahedral, tetrahedral. It explain the magnetic behavior, paramagnetic, diamagnetic, unpaired electron. But lot of assumption we are having here. It is giving us quality data, whether it is paramagnetic and diamagnetic, but it is not giving the proper quantity wise what percent is exact amount is difficult to predict from this. It cannot explain like a specific color of the compound. We can't tell based on this data. It is not telling about the thermodynamic property like change in enthalpy, change in internal energy, correct? Overall how entropy is changing, no data is given based on the thermodynamic. We are not talking about the stability, the thermodynamic, how it is less stable or more stable, because you will see in crystal field theory we will talk about the energy means thermodynamic stability, kinetic stability, but not here, correct? It is not telling us exactly how it is tetrahedral and square planar in the four, like we can get idea, but detailed explanation was not given at the time of the crystal field valence bond theory. And though based on the idea of the crystal field, all of us know कि fluorine, chlorine, bromine, iodine are the weak ligand. Then carbonyl, cyanide, ammonia, C2O4, 2 negative, these are strong ligand. We know this from the crystal field theory. But even if anybody start from the scratch, th- they will ask only one question, sir, how we will get to know whether it is a strong ligand or weak ligand, right? You get this question.
Yes, sir.
So this is not explained by the valence bond theory. Your valence bond theory in detail is done. Today if I don't get time for the uh, electric field chapter, it's okay. I'll definitely give question, but not many. But I will finish this coordination compound. So tomorrow I'll take one extra class for the physics. Okay, done. Crystal field theory, I need to explain on the notes, not through the NCRT. Through NCRT, it is boring and you can't understand NCRT line by line. And that is the
We need
problem
to
with the
draw the
crystal field
whole
theory.
structure thing, so it won't be
Yes,
possible.
proper structured form. Okay? And let me ask all of you from how many are Chandana and Pratigya are facing network issue. Sarah, as of now, you faced issue mostly in the crystal field theory.
Yes, sir.
Marinder, crystal field theory.
Yes, sir.
Jordan, crystal field theory.
Yes, somewhat.
Anvita, crystal field theory.
Yeah, sometimes.
Yeah. So maybe you can solve some question, but there is always difficulty while you do crystal field theory. Pratigya, do you face problem in crystal field theory?
हाँ सर, वो लास्ट वाला बता दीजिए फिर
हाँ,
से, नेटवर्क
हाँ,
इशू था।
हाँ. So that's the reason why I am taking it separately because we can directly start crystal field theory. Okay. So we have to do a lot of questions and let me see some questions also if we can get.
So when can we do the doubts for quotation compounds?
In evening,
Okay,
where
sir.
this this uh, which of the following compound exhibit the highest paramagnetic behavior? Highest paramagnetic, it means most number of unpaired electrons. In that case, ammonia is the strong ligand. You know this, correct? Titanium 3 positive means 3D1. Chromium 3 positive means 3 unpaired electron. And this is explained purely based on the your crystal field theory, not valence bond theory.
So
This
is
is
it
very good
option
question.
D?
This was the question wavelength of the light. It was based on the energy. What was the question number? 64 something, na?
So I think it was 63. Huh.
So in this 63, right, what happened?
So you stop sharing screen.
So in this, you are checking where you have the maximum paramagnetic behavior. Just consider the same thing. Like consider your first 3d orbital and then 2d orbital up. In titanium electronic configuration is 3d1, so only one electron. Chromium 3 positive configuration is 3d3. Even if you have strong ligand, still it will be unpaired. Anvita, now you got idea? Anvita and Jordan.
Ah,
Yes,
so
Even you have strong ligand ammonia, still it will be unpaired because you always start with unpaired. Then you cause pairing if there is a fourth electron. Whether fourth electron should go to Eg, this is Eg, this is T2G. Whether it should go to Eg or it will cause pairing. Cobalt 3 positive. Cobalt 3 positive, it means 3d6, correct? And it will cause
according to
pairing.
EBT, like even if there are only three electrons, uh,
Uh,
we will pair one of them, right?
no, 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 we will not.
Even
Because
EBT.
for pairing will start only when there is uh, at least one unpaired electron, right?
So basically, even number should be there for pairing to occur, no, sir?
Even number?
Like even number of electrons, so that if there's a strong ligand in place, they
No,
can
even
pair.
number of electron does not matter. Even in the odd number of electron, you can do the same stuff.
So, sir, if like we do in VBT like five, like the whole D's the subshell, like proper
Uh,
five orbitals, and we have
right.
three electrons.
Uh,
So we will
it
of
look
course
like it
first
will cause pairing.
what, sir?
It look like it will cause pairing,
But it won't.
but it won't.
So at least four we need to start pairing.
Yes.
But it has nothing to do with like
Valence bond
even.
theory. Yes, we have to focus on the crystal field theory in that case.
So because this is strong, if this is a strong ligand, so the
Battery
splitting
could
will
be.
be bigger. So the energy gap will also be higher, and
Yes.
therefore it will fill the energy like
In case
the
of strong
center.
ligand, this will happen if there is a strong ligand, energy gap will be higher. Then it is difficult to go to the higher level. So it will start causing pairing. That we'll discuss in the crystal field theory. Don't worry about this.
Okay,
So,
sir.
Yeah.
so one last thing, like basically what I understood is like uh in even in VBT, if
Hmm.
even if we have strong ligands,
Hmm.
like until unless we have four electrons, we do not start pairing.
Exactly.
Even in VBT.
Yes.
Okay, got
And the reason is crystal field theory.
it. Right.
You can segregate them.
Hmm.
Got it? Just give me a minute. हाँ सुनो हाँ जी ये लाइव में है नहीं 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 ये लाइव में लाइव क्लास वाले सिर्फ ना यूट्यूब we'll do this last question or maybe second last question. So what is happening in this case? Very good question to explain this behavior. कि you will always see your 5 orbital into the form of T2G and EG always. And in crystal field theory we'll discuss कि even if you have strong ligand, this impact will start once you have at least 4 electron. If you have 3 electron, doesn't matter whether it is a strong ligand or weak ligand, no impact. Understood? And with that was your question, right? Your statement.
So could you repeat?
Key example, if you have 4 electron, only then you can see the difference whether you have strong ligand or weak ligand. Before that, if you have 3 electron or 2 electron, behavior will be exactly same both in the strong ligand as well as weak ligand.
Yeah, so
Mm.
basically.
Yeah, only unpaired electron.
Yeah, because you said no pairing until unless we have four electrons. So yeah, basically it
Exactly.
will act as a weak ligand.
Yeah, everything act as a weak ligand. So here, example, here you can see you have total 6 electron. So what will happen? These 6 electron, first you will see first 3 unpaired. Then pairing will start fourth, fifth, sixth. Then so all the electron will be filled in T2G only. Zinc 2 positive. It means 3D10 already paired. Doesn't matter. So where you have maximum number of unpaired electron in chromium, because chromium have 3D3. Answer will be B. Understood? Because here 1, in B you have 3, in C all are paired. So no unpaired electron, even in D all are paired. Got it? Any other question? The strongest bond we'll discuss in the other topic. Meaning paramagnetic. Last question of this class. Chromium 2 positive. Chromium 2 positive will be like 3D4. Correct? Manganese 2 positive will be 3D5. Iron 2 positive will be 3D6. and cobalt 2 positive will be 3d7, which is already given. And where you will see minimum paramagnetic behavior means maximum pairing. In this case, what will happen for electron? In this case, 1, 2, 3, 4, 5. In this case, you have 6. So everything is paired. In this case, there will be 7 electron. 1, 2, 3, 4, 5, 6, and then there will be 7th. So where you have minimum, should it be iron? Because no unpaired electron. Minimum paramagnetic ना means maximum. हाँ जी सरकार, बस खत्म हो गया, ये तो ये लास्ट है. Done? Understood, guys? Any doubt? They are asking minimum paramagnetic means there should not be any unpaired electron. In FP, you don't have any unpaired electron. Yes or no?
Yes, sir.
Done.
Yes, sir.
So that is
Yes,
about
sir.
this class. You need 1 hour break, so take break. Keep revising your main test. Go through it. Focus on what we are doing currently. The coordination compound. Make it perfect. Next class will you should be like I am best in coordination compound. Okay. So finish it.
Yes, sir.
We'll see you at 2. And send me your notes.